السلام عليكم ورحمة الله وبركاته. يا مرحبا بالجميع ونورتونا في أنابيب كاتاليست ويبنر 2021. معاكم إبراهيم عبد الله المطيري، مهندس بحث وتطوير في شركة أنابيب. Welcome ladies and gentlemen to Anabeeb Catalyst Webinar 2021. This is Ibrahim Mutairi, Research and Development Engineer. In this section, I would like to talk about a technology that might be the future of industrial services. To those people who really want to eliminate the manpower from entering hazardous environment and confined spaces during catalyst unloading activities, the unloading robot will be your great choice. The unloading robot has been developed to eliminate people from entering hazardous environment, confined spaces, and replace manpower as much as possible during inert entry. Let's have a look of the robot design to imagine how the robot looks like. The design will help the robot to unload the catalyst in perfect way. First of all, the tracked design of the robot gives it a steady platform. The robot is sufficiently long, which gives it good ground pressure for smooth driving on the catalyst while vacuuming, and it's fit up to 24-inch manway. The robot has a mechanical arm to break the fuel catalyst if necessary. It has a camera to monitor by a remote and record for inspection purposes. It is operated remotely, as I mentioned before, continuous operation. Also, it can be operated up to 100 degrees Celsius. It can be worked for all types of conditions. Also, zone zero. Also, it can be operated under the water. These features give you the chance to work without 100% of cool down of the reactor, which you can finish before the schedule or ahead the schedule. After we get familiar to the unloading robot, let's have a quick comparison between the robot itself and the old way, which is the conventional or the manual way of the conventional unloading. The robot, let's start with the robot, then we will start with the conventional unloading. The robot, the main things of the robot: eliminate man entry, which is eliminate, not minimize. Only the robot can be inside the reactor and it can be remotely controlled from the top. Faster unloading rates, which give you the chance to put the robot inside the reactor without 100% of cooling down of the reactor. Required less manpower, less resources, less duration, of course. In the conventional side, of course, it required the inert entry and required more manpower. Also, it had slower than the robot for the unloading activities. Now, enjoy watching the video of the robot to explore more.
The development of Rover, a remotely operated vehicle designed to significantly reduce and even eliminate personnel entering confined spaces to unload catalysts, substituting risks to personnel with innovative technology. Purposely built to fit through most standard manways, Rover gets lowered into a reactor through its top access point. Remotely controlled by an operator, the sturdy track design and guy wires allow it to move freely within the reactor, as it unloads essentially the entire contents at rates comparable to or better than conventional unloading. Rover operates in all types of conditions, including underwater, and in temperatures up to 100 degrees Celsius. It is also certified to operate in Zone 0 classified areas. Moreover, Rover does not need to take frequent rest breaks, unlike its human equivalent, therefore shortening catalyst replacement schedules. For large reactors, multiple units can be used simultaneously to minimize schedules further. Rover is equipped with camera, lights, and a vacuum hose. An additional mechanical arm can be customized with tools for specific applications, such as removing fused or coked catalysts. Since 2017, clients have recognized the outstanding value of Rover. They now specify it in their contracts as a requirement for unloading reactors. Proven to minimize confined space entry significantly, it also reduces replacement schedules on challenging jobs by up to 30%. Specify Rover for your next catalyst replacement job.
Thank you for watching the video. Let us continue. Let's have a real example of chloride treater reactor. The challenge was the total volume of chloride treater was 150 meter cubic of a spent adsorbent in a 5 meter in diameter, and the client forces to minimize the inert entry. The solution was the robot unloaded the spent adsorbent and minimized the inert entry. The robot passes through 24-inch manway easy. Unloaded the entire bed without man entry. What is the outcome? Outcome was the robot unloaded the spent adsorbent faster, more productive, no stops for regular breaks. Over 99.5% of the spent adsorbent was unloaded without man entry. The entire adsorbent change out finished ahead of schedule. These are some examples of previous assignments. As we see from the list, the robot has been operated in different types of reactors. Most of these reactors, the robot was a great solution. For example, the total volume of mercury removal unit was 50 meter cubic, and the volume unloaded by the robot was 49 meter cubic, which means that almost 100% of the spent adsorbent was unloaded without man entry. We can summarize the main points of the robot by safer unloading, faster unloading, reduces man entry by more than 98%, proven working technology with experience in catalyst unloading worldwide, cost-effective technology. Thank you for watching the robot unloading presentation. Welcome back again. In this section, I would like to talk about the second technology of unloading catalyst activities. During unloading activities, some of spent adsorbent is fused or cooked hard to unload without the use of jackhammers. Using of jackhammers by workers required more effort, which may lead to accident or damage the reactor internals. Advanced wet dumping was developed based on proven technology to quickly and effectively remove fused catalyst. Advanced wet dumping has three main steps to unload the fused catalyst. First of all, we install the drilling rig on the top of the reactor manway. We install the drilling rig from the top of the reactor manway to drill, this is the first step of the advanced wet dumping, to have a drill in the center of the fused catalyst, and from the bottom, from the dump nozzle, to drill again, so to have a way in the center and way out while it's drilling, and to flush the catalyst out. The second step, which is unloading. Unloading by primary drill head and the cleaning nozzle. When it's drilled, it has a high pressure water to break the fused catalyst and flush through the way out from the dump nozzle. The third step, which is final clean by the cleaning nozzle. It can clean and flush the reactor. This is the primary drill head with high pressure water nozzles to break the fused catalyst while drilling. These are the advanced wet dumping major equipment to drill and unload the fused catalyst. As we see from the slide, this is the setup of equipment from the top picture, and how the primary drill head drills and breaks the fused catalyst from the bottom picture. Now enjoy watching the video of advanced wet dumping to explore more.
Advanced wet dumping technique is an enhanced wet dumping solution that combines drilling and hydroblasting technology to remove virtually all of the fused catalyst in the reactor without having to enter the vessel. It significantly decreases the amount of wastewater generated and maintains the integrity of the internal components, as no mechanical equipment is used during the process. The process begins by clearing a path through the spent catalyst by drilling down from the top and hydrolancing up from the bottom at the same time. Once a clear path is achieved, different drilling nozzles are used to remove the remainder of the spent catalyst, which is flushed out from the bottom dump nozzle. In certain multi-bed reactor designs, we can drill straight through the interbed plate between the top and bottom beds, allowing all of the spent catalyst from both beds to be discharged through the bottom dump nozzle in a single step. The spent catalyst exiting the dump nozzle feeds into a spiral classifier, which drains the water from the spent catalyst before it drops into UN-approved containers. The water is separated, cleaned and treated in a closed-loop system prior to being reused. Commercially proven, our advanced wet dumping technology is safer, faster and more reliable than conventional unloading methods. Virtually all the fused catalyst can be unloaded without having to enter the vessel, thereby reducing risks to personnel. The unloading can be carried out under normal atmospheric conditions, as the water helps to passivate the spent catalyst. Catalyst replacement schedules are reduced significantly due to faster reactor cooldown times, combined with higher and more consistent unloading rates, meaning the entire change-out duration can be guaranteed. This all adds up to a substantially more effective and efficient solution that delivers increased value and lower overall costs to our clients.
Thank you for watching the video. Let us continue. This flowchart explains what you saw in the previous video. Let us go through the advantages of advanced wet dumping. We have four main advantages. The first advantage, which is commercially proven. Advanced wet dumping has been used by advanced oil and gas companies for many years. Improve safety. Over 90% of the fused and hard catalyst can be unloaded without man entry. Faster schedule. Unloading time is faster than the conventional loading. Better reliability. Water can be treated and recycled to significantly reduce waste and fresh quantities needed. These are some examples of advanced wet dumping experiences in several countries. Wastewater savings by advanced wet dumping is much more than normal wet dumping, which saves at least 85% of wastewater. The robot and advanced wet dumping has been developed by CR Asia. CR Asia is our Far East sister company. Now these technologies are available in GCC via Anabeeb. At the end of this session, I would like to thank you for your attention and I hope you enjoyed the presentation. I wish you all the best. Thank you.